Hello everyone, welcome back to Pre-Algebra. Today we are doing section 3.3, which is rounding decimals. Very straightforward thing, just has a little bit of a twist to it from rounding whole numbers. However, before we begin, of course, I've got a lame joke for you. What do you call 4 bullfighters who are stuck in quicksand? Cuatro cinco. Those of you who are familiar or not familiar a lot, it's a play on words in Spanish. Cuatro, which is 4, cinco, which is 5. So cuatro cinco is 4 bullfighters that are stuck in quicksand. And I said yesterday that I would toss that purple marker out, and I obviously didn't. It's now going to be in the trash. Section 3.3, rounding decimals. Let me show you something, just comparing the ways in which you would round whole numbers and a decimal number. So let me see what one I want to do. This is 8.6075. Remember that I said when we're actually calling numbers by name, it's much easier to say 8.6075. They want you to make sure that you understand that the way you exactly, specifically, and correctly name this number, this would be 8, the decimal point is pronounced and, 8 and 6,075 10,000ths. The way that you know how to name the number is you call the last decimal place. Tenths, hundredths, thousandths, 10,000. So it's 6,075 10,000ths. If we had 8.0005, you don't say anything for those zeros, those are just placeholders. So this would be 8 and 5 10,000ths. So now with that brief review, let's go back to 86075. First, I'm going to treat this rounded just as a whole number. We have 86,075. It's not 86,075. There's no decimal point. So you just read it 86,075. First, we want to round it to the nearest 10. When we round to a specific place, we're going to round it to the nearest 10. What digit's in the tens place? It's a 7. This is a 5 or greater, so we round up. So we have 86,080. This is how this is rounded to the nearest tens. I'm just going to go tens. Now, if we wanted to round 86,075 to the nearest hundred, a 0 is in the hundreds place. We have a 7 in the place directly to the right of it. 7 causes us to round up. 86,100. This is rounded to the nearest hundreds. Rounded to the nearest thousand would be 86,000. And then, of course, rounded to the nearest 10,000 would be 90,000. All of your kids should be very, very competent in rounding whole numbers. And I want you to see this interesting pattern here. 1 0, 2 zeros, 3 zeros, 4 zeros. Mentioned in the video and in class when we're talking about place value and understanding why you have zeros, and the fact that in a decimal system we can create any number imaginable by simply using 10 characters, the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. What tells us how big a number is what place value that digit is in. So you have to have zeros with whole numbers, because if you didn't have a 0, what would you think we had going on? Or what could you think? If you didn't have this extra 0 at the end to hold the place, you'd have 8068, 861, 86, and 9. And that's a pretty crummy marker also. It's a different purple one, but I'll get rid of that. I guess today purple is just not my friend. See if this one works any better. 8608, 861, 86, and 9. Obviously this number is not 9. We know it's 90,000, but that's because we have these zeros here telling us that the digit is in the 10,000s place. So we have 9 times 10,000, or 90,000. Now, let me go ahead and show you what we do when we round decimal numbers. We're going to use this exact same set of digits, but we're going to say that this is 8 and 675 10,000s. So first, what we're going to do is we're going to round to this second place in here. What is this going to be? Tens, hundreds, thousands. We're going to round to the thousands by looking at the 7. It's going to round up. We're going to have 8.608. These are going to round just exactly the same way that we did with our whole number. And this is rounded to the thousandths place. We round to the hundredths place. You have 8.6. Let me back up. I left the 0 here because I want to illustrate something. It's not time to do this. This is not rounded to the thousandths place. Because remember, the way that we name a decimal number is we repeat the number, we read the number, and we say the name of the last decimal place that there is. So this is actually 8 and 6,080 10,000ths, but we want it to be to the thousandths place. So I need to erase that 0. Now we're going to round to the hundredths place, hundredths place. 0 is there, 7. This is going to round up. So this would be 8 and 61 hundredths. To the tenths place would be 8 and 6 tenths. And then to the nearest whole number would be 9. This is rounded to tens, hundreds, thousands, and 10,000s. But we have these zeros here. This is rounded to to thousandths, hundredths, tenths, and whole numbers. And we have not annexed those extra zeros on there. And this is the difference in what a rounded decimal number looks like and what a rounded whole number looks like. You do not add the extra zeros on here so that you have the same number of places that you did in your additional problem. Because then you would be naming all of these as a decimal number to the 10,000ths place. This would be 8 and 6,100 10,000ths, 8 and 6,000 10,000ths. Without belaboring the point, the reason that we do this is very, very important when you deal with sciences and with upper level maths, which of course is beyond the scope of this course. But what I want your kids to understand, and you guys, I guess some of you to understand also, is that this implies, with these extra zeros at the end, this implies a very different degree of precision and of accuracy. This number in science is not the same. So what looks like just extra zeros as placeholders, it's very different when you're rounding decimal numbers. So with decimal numbers, when you're rounding to a fractional place, you drop the extra zeros. And that's what I wanted to point out from there. Now, how are we going to estimate sums and differences with decimal numbers? We're going to do that exactly the same way that we estimate sums and differences with whole numbers. For example, let's say that we have n is 13.96, 8.74. 13.96 plus 8.74, and our problem tells us that n is equal to 13 and 96 hundredths plus 8 and 74 hundredths. And our instructions tell us round to the nearest tenth. Excuse my abbreviation there. Round to the nearest tenth. What are we going to do? We're going to look at the digit that's in the tenths place. And I can't believe I did this again. This is the second time I've recorded this video. I'm going to change this problem right now. I don't want this to be 13.96 just exactly yet because it adds in an additional little twist that I need to show you first. So I'm going to change this to 13.86. What do you do when you're estimating sums and differences with decimal numbers? You have to make sure that you round to the specific place that they ask you to round to, just like you would do the same thing with whole numbers. The 8 is in the tenths place. The 7 is in the tenths place in this number here. This is going to round to 13 and 9/10. This will round down to 8 and 7/10. Our equal sign tells us that the value of this variable n is exactly equal to the sum of these two decimal numbers. If we change this to, looks like two waves or two of the accents over the n in Spanish words, over the nye. This says n is approximately equal to, this lets you know that you're estimating that this answer over here is not exact. The equal sign would be exact. The is approximately equal to sign is exactly that. It's close, but it's not specific. So we're going to round these two digits to numbers to the indicated place, which would be 13.9 plus 8.7. So n is equal approximately to 22.6. Some of your kids can do that addition in their heads. They may not use a calculator. They might not use something on their phone. If they want to show 13.9 plus 8.7, indicate that out to the right-hand side in your scratch section. 13.9 plus 8.7, 7 and 9 is 16. We carry 1 to give us 22.6. Or 22 and 6/10. This has been rounded to the nearest tenth. No extra zeros on there, even though we started off with decimal numbers to the hundredth. Now, let me show you an important difference here. Some of the kids are going to jump on this and say, Miss Betsy, this is not right because you said you don't put extra zeros at the end of a decimal number. And that's why I want to show this to you, because it's yet another technical difference. We're going to take our problem that I had up here originally. I had n is equal to 13.96 plus 8.74. We're going to round this again to the nearest tenth. The 9 right here is in the 10th place, correct? The digit to the right of that is a 6, which means that we round up. How do you round 9 up? 9 plus 1 is 10, so it means that's going to become a 0, and you carry a 1 over here. So we have n, that's an interesting looking n, way too early on a Saturday morning. N is equal to 14 and 0 tenths plus 8.7. 14 and no tenths. Why is it that I have a 0 here at the end of a decimal number that I've rounded when I just finished saying you don't do that? The reason here is very different because we are rounding to the nearest tenth. The only way that we can show a tenth here is to actually have a 0 there, so we can say 14 and 0 tenths. And this is important, again, in applications of science. So this is rounded to the nearest tenth. Then you would have that n is approximately equal to 22.7. So that's the end of section 3.3, where we're talking about rounding decimal numbers. I'll see you next time.